And we're going to learn how to go back and forth between polar and rectangular. You make some really cool graphs with polar stuff. This is just a little bit of an expose, like just trying to expose you a little bit to a different way of graphing. Really the whole point of this, okay? So, just another way to look at things.
Oh, wait, we're not in this book.
We're in the white book right now. So, we're going to start by looking at the main parts of a coordinate polar system. We, just like rectangular, there's a starting point. And our starting point right here is in the center. It's called the pole or the origin. That really hasn't changed. And the polar axis is the ray drawn from the pole to the right. So, instead of a point being xy, we say r theta. R is like the radius, and theta is the degrees that you move. Okay. In polar, this is 0 degrees. So we start in the same place that we're used to starting. Yes. Yeah. So this is kind of where we start from. This is where we start moving from, just like what we have been doing. An R can be positive or negative, so can theta. The sign indicates the direction of through the pole. And we'll do some examples. We'll show you what we mean. So let's label some things. So we have this. This is the origin. On most of these, I think that I put on here, this would be like 30 degrees, 60 degrees, 90 degrees, etc. They just go by 30s around there, which we're used to drawing as well. So, let's start and do an example. We'll see how this works, okay? So the first point we want to graph is 4 at 45 degrees. So we don't have a 45 degree line on here. So 45 degrees is between 30 and 60. So maybe just, and you could just sketch it on there. It doesn't matter. I just cut between 30 and 60, and there's your 45. And so here's how this works. So your radius is 4, your theta is 45. So I go to the 45 line, and my radius is 4, so I'm going to go out 1, 2, 3, 4 circles. And that's point A.
You count the origin?
Nope. So 1, 2, 3, 4. Is that okay? So for B, what's the difference? So we need to still be on the 45, but the radius is -6. So instead of going out 6 this way, we're going to go backwards 6. 1, 2, 3, 4, 5, 6. So the radius just tells you to go the opposite direction when it's negative. And then C is at 7 and then 240. So this is 180. So this is 210. Here's 240. So start at the origin, go on the 240 line, and count out 7. So it puts us right here. And then D, the theta is negative, so we're going to go back. -75 is like right here. And we got to go out 3. And that's where D is.
How is 7 right next to -6?
It's all about the angle. We went over to 240 degrees.
Oh, okay. I got it.
Is that okay? Yeah, you got to pay attention to both. That's how you plot points in polar. And of course, if we do it in degrees, we can also do it in radians. Yeah, we can. So this is 0 radians. So instead of 30, this is pi over 6, and pi over 3, pi over 2. 4 pi. Oh, and of course we threw some 45s in there. Okay, then we plot them. I know there's not 8 circles on here, so another thing we can also do is we can count by 2s. And so to go out so get on the pi over 6 line, and then we're going to count out 8, but I'm going to count by 2s. 2, 4, 6, 8. So there's A. And then for B, you need to go negative 3 pi over 4, so that puts us right here. And then count out 5, 2, 4, and 5's right in the middle. And then for C, where do we need to go? Where do we go first? Find what angle? 2 pi over 3, so find your 2 pi over 3 line. But what's the radius tell us to do? Yeah, we got to go backwards 7. 2, 4, 6, 7. So I'm going to do D. So negative pi over 6. And then what? Back 9. Are there questions with the plotting? Makes sense? Okay. Of course we want to know how to go back and forth between the two. Between rectangular and polar. So here's the relationship. And once again, like most things that we're going to do, it's based off of right triangles. So here's our theta. That's 90 degrees right there. Our R, if you envisioned a circle, that's the radius part. This is X, this is Y. And so this works because of the Pythagorean Theorem, because it's a right triangle. So that's handy. And they set up the trig ratios right here. But the really important parts are right here. Is they solve this one right here, they solve for Y. So they multiplied by R and they got this. And this one they solved for X, and so they multiplied by R and they got this. And these are the common things we're going to use to switch back and forth between the two. Okay? And don't forget about tangent. He is also important. Okay. So where we're going to first start is going from polar to rectangular. So for point A, what do we know? We know R is 5, and we know theta is pi over 6. And to go into rectangular, I need to know what X is, and I need to know what Y is. But I know X is equal to R cosine theta, and I know Y equals R sine theta. Well, I know R, and I know theta, so can we figure out X and Y? Yeah. So let's draw our triangle where it lives. So pi over 6 is in quadrant 1. So let's draw our pi over 6 triangle. What goes across from the pi over 6? Yep, the Y. What's the number? Nope. 1/2. This is root 3 over 2, and this is 1. Are we okay with that? And now let's fill these out. So X equals my radius, which is 5, times the cosine of pi over 6. But I have my triangle, so do I know what the cosine of pi over 6 is? Yeah. So What is going on in the hallway? Okay. So the cosine of pi over 6 is equal to what? Yep. And when you multiply that, I would just write that as 5 root 3 over 2. Because, of course, in the directions they said exact. And we're going to do the same thing for the y, but instead of cosine, it's the sine. So y equals 5 times the sine of pi over 6. Well, what's the sine of pi over 6? 1/2. And 5 times a half, I'm going to just write it as 5/2. So this is how we go back and forth between the two. So let's go ahead and do B. I've totally already run out of room. Hopefully you guys wrote smaller than I did. I gotta do this on another sheet of paper. Okay, so for point B, they give us -3 and 3 pi over 4. So what do they tell me when they tell me this?
R and theta.
Good. So r is -3 and theta is 3 pi over 4. And how are we going to figure out the x part of our coordinate? We're going to draw our triangle. So 3 pi over 4 is quadrant 2. The reference angle is pi over 4. So what are our side lengths? Yep. Square root 2 ones. Good. Yes. The angle is going to be there, and the negative is going to make it work out. I was going to actually show you guys that in a second. Good question. Don't let me not show you. Okay. Okay. So x is equal to your radius times the cosine of the angle. Oh, Miss White forgot the negative sign. Don't forget that negative sign. Okay, so instead of cosine of 3 pi over 4, what's the cosine of 3 pi over 4? -1 over root 2. And here's what happens. It's going to actually, it'll kick it back over to where x is positive because of that. Because the radius was negative. So you get 3 over root 2. And go ahead and leave it as 3 over root 2. That's totally fine. And then for y, use the sign. So y equals -3 times 1 over root 2. So -3 over root 2. Now, I like the question that Josh asked, and I was going to show you this. I'm glad he asked it. So he's like, but the negative would kick it into quadrant 4. So if we were to graph this on a polar axis, and really on your homework, this is all you want from me is to like draw rough circles. I mean, really, it's just sketching, okay? It doesn't have to be perfect. You don't need a compass. So 3 pi over 4 would be right here, right? But the radius is -3, so that puts it down here in this quadrant. You're going to draw whatever the angle is here, because whatever the sine of the radius is it's going to kick it where it needs to go. And if you were to graph 3 over root 2, you would go this way, and then -3 over root 2, you would go down. So just the way that the formulas work out, it's going to put you in the right place. You don't have to add more to yourself, okay? So wherever the angle says it lives, that's where you're going to draw your triangle. And the sine will be dealt with the radius. But good question. I like it. Is that okay? Okay. And then C, last but not least, point C. Everything's negative here. Okay. So our radius is -2. And our theta is -5 pi over 6. So where's -5 pi over 6 live? Not is negative, so it'd be in the third quadrant. Is that okay? Is everybody okay? Is everybody okay back there? So our reference angle is pi over 6. What goes across from a pi over 6? Yep, and don't forget that negative sign there, and then this is negative root 3 over 2. Now let's do it. So x equals our radius times the cosine of theta. What's the cosine of that? Negative root 3 over 2. Negative, negative. Positive. And what happens to the 2's? Cancel. So x is equal to root 3. And then y. Okay, so what's the sign of that? Negative a half? Oh my gosh, what's negative 2 times negative a half? 1. I find it easier to go from polar to rectangular. Right now we're going to go backwards. Okay? It's got to happen. It's got to happen.
It's right here.
Now they're going to tell us that our r has to be positive, and that's good because we're going to use the Pythagorean to figure out what r is. Because when they give you something in a rectangular, they're giving you an x value and they're giving you a y value. So remember that box, the very first formula was the Pythagorean theorem, right? Which was r squared equals x squared plus y squared. So I know that for point A, I know r squared is equal to my x squared plus my y squared. So I know r squared should equal to 1 plus 3, which is 4. And the trick is we're going to take the square root. But when you take the square root, how many options do you have? 2. By them saying r is greater than 0, they're telling us which option we're going to choose. So in our case, our r is going to be 2. Is that okay? Okay. And then to figure out theta is a little bit trickier. Remember I told you don't forget the tangent. He's important. Here's where here's why the tangents are key. Okay. You okay? Okay, just checking. So what quadrant does this live in? Quadrant 1, right? Positive, positive has to be in quadrant 1. So that makes where we're going to draw our triangle in the same place because our radius has to be positive. So we're going to draw our triangle in quadrant 1. So I know the tangent of theta is equal to my y value over my x value. So in quadrant 1, there it is. There's our triangle. Is this a special? This is a special. So what's this angle? What goes across from the root 3? Pi over 3. So our theta is pi over 3. So our answer was 2 pi over 3. Oh, you can barely see that. So let's look at for B. So let's find our r first. So we're going to use Pythagorean for that. What does your r end up being? 2. It's 2 again. And then the tangent of theta is equal to negative 1 over negative root 3, which is 1 over root 3. Now we got to figure out which quadrant we're going to live in. So where rectangular, what quadrant does the rectangular points put us in? Quadrant 3. So that's where we're going to draw our triangles in quadrant 3. 3, -1. Is that our special? It's a special. I usually ask what's across from the 1/2. If you divided everything by 2, that's where you get. But so what's this angle going to be? What's a reference angle? Pi over 6. Now the trick is, where did they tell us our angle was? Our angle is from -pi all the way to +pi. Yes? So I'm going to move this a second. I'll put it back in just a second. So here's 0, right? We just found out that this is where we're living. Can I go all the way? Can I go positive this direction? They told me I'm only allowed from -pi to pi. This is pi. Am I allowed to go past it? Oops. I can't. So I can't go in the positive direction. So that forces me to go in the negative direction. So now I'm going from 0 to here. So now I'm going to think of it as -pi. I'm 1/6 away from -pi. So how far are we that way? -5 pi over 6. You have to pay attention to the interval. You can't just make an assumption. Is that okay? So, because we're not allowed to go positive that far, we're going to go backwards. We're 1/6 away from a -1, so we're at -5 pi over 6. Okay. I'm going to show you how to use your calculator. I'm going to modify these rules a little bit. So let's get our calculator out. Our calculator has built-in conversions. You could do it the long way like we just did, or you can do it the conversion way. However, the catch is when I ask for it in exact, guess which way you have to do it?
Calculator.
No, you do it in calculator, I count you all wrong. Because part of life is following directions. Okay? It's called laws. Called your boss. Kind of has to happen. Okay, so this is given to us in rectangular. So this is my x and this is my y. Okay, so here's how it works. And we want our theta in degrees. So if we want our theta in degrees, which mode should we be in? Degrees. So make sure we're in degree mode first. And I'm not. If you hit the second in the apps button, it's the menu angle. Look at number 5 and look at number 6. The R means we're starting in rectangular. The triangle means we're going to go to polar, and the first time we do it, they're going to give us the radius. So we're going to have to do each of these twice. So hit number 5. Because they gave us rectangular, that's where we started. So we're going to make sure we start with the R. And then you type in the point. So -6.434, comma, 4.023. That's the radius. The comma's right above the 7. And so you plug that in, and that tells me right there that they pumped out the radius part of my point. So right now I know the radius. So 7.59 we'll go with. And now I want the theta part. So go back to the angle menu, second apps, and look at number 6. What part's that going to give you? Your theta. And then you retype in the point. And there it is. So 147.98 degrees. that okay? Now, we have to think about this one. They didn't tell me which... This is in polar, so this is my r and this is my theta. Do you think that theta is in degrees or is in radians? It's probably in radians. If they don't tell you, assume it's a radian, unless you could tell it's like 143. I mean, that degrees, but they'll usually put the degree sign. So if they don't put a symbol after it, what are you going to assume it is? Radians. So because they give this to me in radians, what mode should we be in? We need to be in radians. So switch your mode back to radians, if it wasn't already. And go back to that angle menu. Look at 7 and 8. So 7 and 8, they start with the P, so that means we're starting in polar, and we want to go to rectangular. And the number 7 is going to give you the X part of your point, and number 8 is going to give you the Y part of your point. So 7, and then you type in your point. So there's the X part. And then go back and do the number 8. Are you okay with the calculator part? Okay. Not too bad. The last types of these we're going to do are where we're going to change function-wise. Tomorrow we're going to learn how to do the cool graphs, sketches of them. They're pretty neat, not going to lie. They're kind of fun. So we're going to change these to polar form. So the big thing with polar form is you want to get rid of every x and every y. That's what you want to get rid of. And we want to solve for r if at all humanly possible. It doesn't always work out, but we'll try, okay? So remember that table or that little box where we had r squared equals x squared plus y squared. We had x equals r cosine theta and y equals r sine theta. We're going to use this stuff and we're just going to replace if at all humanly possible. Whenever I see squareds, I hope I have an x squared and a y squared. Do we have an x squared and a y squared? So what are we going to replace it with? R squared. So this right here, we're going to replace, we're going to make it r squared. Mine is 2, and we need to get rid of the x. What are we going to replace the x with? R cosine theta. And that equals 0. And the nice thing is it equals 0, so 0 product property. So if I can get two things multiplied together to make a 0, I can solve this even farther. So is there any way I can simplify or factor this thing? Yeah, what do they each have? Yeah, pull an R out. And 0 product property says two things multiplied together make a 0, that either that one equals 0 or this one equals 0. Now, r equals 0, that means we don't have a radius. Is that going to be very helpful at all? No. Basically, you're at the origin and that's where you live. Spinning in a circle or something. I don't know. Okay, so we're going to ignore him because this doesn't give us anything. And this guy, we're going to solve for r. What would we do? Add 2 cosine. And we'll learn what graph this would make tomorrow. But that would be our answer. Oh, we got a few more of these. Um, 5A is very, very similar to the one we just did. I did that on purpose. Just gets you used to looking for those things. So what are you going to change first? Good. X squared plus y squared is r squared minus 2. But instead of a y, you're going to go r sine theta. And then what are we going to do? Good. And then zero product property. Good. So r equals 0 or r equals 2 sine theta. Is that okay? The next two, once again, they're very, very similar, but it's done that way to help you guys out. When you have something like this, right now I don't know what just r is, but here's what we can do. Okay, and this works in polar. We're not always allowed to do this in rectangular, but we can do this in polar. So, we're gonna take this. And I really, really, really wish this was an r sine theta. And I really, really wish this was an r squared theta. Because I can change it, because we're going to rectangular. I can change an r squared to x squared, y squared. And I can change an r sine to y. So what we're going to do is we're going to multiply everything by r. And it's not trouble, because remember what we did up here when we factored it out. What did this one give us? Did it add anything complex to our problem? It's kind of like we're just reintroducing that one back in. We're not really changing it because he doesn't do anything to affect the graph of it. And that's sometimes why polar is kind of cool, is because you just basically you're saying, okay, we're at the pole, great. Now what? Nothing. Okay, so. What you're left with is r squared plus 3 r sine theta, and that equals 0 because r times 0 is 0. And x squared plus y squared plus 3y. And you're done. We got rid of all r's and thetas.
Wait, why wasn't all my y squared not x?
R squared is x squared, y squared, and r sine theta is y.
Oh, yeah.
Is that okay?
I thought the plus by the last y squared was an r.
No. So, example 6a is the exact same thing. So what are you going to do to both sides?
Multiply by r.
Multiply by r. So you'd have r squared equals negative 8r cosine theta. I do want everything on one side. We want it to equal 0. So add the 8r cosine theta over. And then replace. So instead of r squared, what are you going to replace it with? X squared y plus 8. Instead of r cosine theta, x. The last one, we do need to use some identities from chapter 4. We got cosine 2 theta. The nice thing is there's an r squared right out here, right? So what I'm going to think of is I'm going to think about, well, what one am I going to use to replace this? What do I have?
Obviously me too, because I'm characterizing.
No, I'm back to normal again.
I'm not.
You have very little tolerance for tomfoolery from grown-ups who should be in classes.
Yeah, and I'm recording.
As do I.
These kids are still learning. But the year's almost over, so
Substituting r squared.
I'm recording right now.
the year's almost over.
I know. We still learn.
Can you edit this part out? Or is it just gonna be
It's going to be there. Okay.
Look at the matrix. I'm back to normal.
Okay. I don't care. I'm teaching. I'm good.
It matters.
That does. Okay, cool. I have no idea what they're talking about. Okay. So r squared, and instead of a cosine 2 theta, if you look at the first one, it's cosine theta minus, or cosine squared theta, sorry, minus sine squared theta. If you distribute the r squared through, instead of thinking as r squared cosine squared, could you think of this as r cosine theta squared? Can you pull that the square out from both of them? Yeah. minus r sine theta squared. So what's r cosine theta? We're changing to rectangular. X. So this is x squared minus y squared, which equals 9. And that's it. And then tomorrow we'll learn how to graph them, and then we'll be done with